Alright, so now that we have learned the derivatives of exponential functions and logarithmic functions as well as their integrals, let's try to apply it to several ways with using our previous knowledge of calculus. So here's an example that I wanted to show you guys. So here we have e to the xy equals 3y minus x. And we're supposed to find the derivative. So find dy dx. So this might look a little intimidating at first, but it's as long as you follow these steps, it's not too hard. So basically, what I'm gonna do is I'm gonna take the natural log on both sides. So ln of e xy equals 3y, the natural log of 3y minus x. And this is because it makes the problem a lot simpler, as then this exponent will go down here. So you don't have to worry about it messing up with your e to the x. In case you have trouble taking the derivative of this. So basically the exponent's going to go down to the coefficient. So we get xy ln e equals ln 3y minus x. So ln e is just 1 because that's just log base e of e. You get xy ln equals ln 3y minus x. So now we're ready to differentiate. So I'm going to take the derivative on both sides. So these two are two separate functions, and none of these are constants. So since they are two separate functions, we're going to have to use a product rule, which is basically the same thing as, say if x is u, and then y is v. When you take the derivative of this product, it is just u prime, that looks like a v, u prime times v plus v prime times u. So now let's apply it. So we get the derivative of x is just 1, so, and then times y is y, so that's y, and then plus the derivative of v, which is y, and that would be 1. So it'd be, and then x times 1 is x. But because we're differentiating with respect to x and not to y, we're going to have to apply the chain rule, which is dy over dx. And then on the right side, we're also going to have to apply the chain rule, but in a different way. So basically, what the chain rule says is, say you get f of g of x, and if you're taking the derivative of this, sorry if my handwriting's bad, you get f prime of g of x, and then, so basically you're taking the derivative outside and then multiplying it by the derivative on the inside, so that's g prime of x. So our g prime of x, so our g of x is 3y minus x, and our f of x is ln x, ln. So we're going to take the derivative of the outside, which is 1 over, and then the inside, which to 3y minus x. Another way to do it is to sub in 3y minus x to be u. So like say if you have um, sorry. Say if you have u and then you equal to 3y minus x, and then find du over dx. That just basically 3 dy dx minus 1. So what you can also do is you could do f prime of u and then times du dx, or in this case you'd basically take the derivative of ln u, so that'd be taking the derivative of this, and then basically if you're doing 1 over ln u, that'll just be 1 over u, right? But since u is not x, since they are different variables, yet you have to multiply by du dx, which is 3 dy dx over dx minus 1. Minus 1. So that's basically what I'm trying to prove. So we have our u here. This is on the bottom. And then we have our du dx here, which is 3 dy dx minus 1. And now we just have to isolate dy dx. So what I'm going to do is I'm going to multiply 3y minus x, this guy right here, the denominator, on both sides so it doesn't get tricky. So 3y minus x times y plus x dy dx, and then equals 3 dy dx minus 1. So now I have to FOIL. So this is 3y squared, and then we get plus 3xy or yx, doesn't matter, times and then times dy dx, and then we get minus xy, and we get minus x squared dy dx, and then that equals 3 dy dx minus 1. Alright? So basically what I did here is I just multiplied 3y by both terms here, so I multiplied this guy by this guy, and then multiplied this guy by this guy, and then I did the same for the negative x. So I multiplied this guy and this guy, and this guy and this guy. Alright? So now we have so I'm going to rewrite it here. So 3y squared, and then plus 3xy dy dx, and then minus xy, and then minus x squared dy dx, and then that equals 3 dy over dx minus 1. So now I have to bring all my dy dx terms to one side and all my non-dy dx terms to another side. So what I'm going to do is I'm going to bring all these terms to the right side. So we get 3y squared, and then minus xy, and then we get plus 1, and then we get x, and then on the right side it's x squared dy over dx. And then we get minus 3xy dy over dx. And then we have plus 3 dy over dx. So now that we have all the dy dx's on the right side, we all know that they share a common factor of dy dx. Thus, we can factor it out. So we get 3y squared minus xy plus 1, and then we get, and that's equal to dy over dx, x squared minus 3xy plus 3. So now to isolate the dy dx, I'm going to divide both sides by x squared minus 3y plus 3. So you get a final answer of dy over dx equals 3y squared minus xy plus 1 over x squared minus 3xy plus 3.